Now we're on page 30 of the Chapter 8 Chem 1 packet. We're going to talk about intermolecular forces. We're going to talk about the strongest ones, which are the covalent network. And as you go down this list, they get weaker and weaker and weaker until you get to the London dispersion, which are the weakest of all. Now technically, intermolecular forces only pertain to the bottom three because the tops don't really have intermolecular forces. They're not molecules, but the concept holds. So on the top, the forces are strongest, so you're going to have the highest boiling point, the highest freezing point, the highest viscosity, but you will have the lowest vapor pressure. So let's talk about what vapor pressure is. If you have a beaker of a liquid, what you can do is realize that it's going to evaporate a little bit. Always. If you leave some water uncovered over time, it's going to evaporate. That's the vapor pressure, the pressure coming off the vapor. If you're very strong, you're not going to evaporate. So for instance, a diamond, which is covalent network, is not going to evaporate, thankfully. So it has a very low vapor pressure, basically zero. However, if you had something like water, H2O, water does evaporate. So it has a vapor pressure. Now, it's not going to have as high a vapor pressure as a polar or as a London dispersion, but it will still have a vapor pressure. So all these down at the bottom are going to be the opposite of what we saw at the top. These are going to have low boiling points, low freezing points, low viscosity, but they will have high vapor pressures, and that's going to help us answer the questions on the following pages for the homework. This first homework sheet is designed to only have H bonding, dipole-dipole, or London dispersion forces for comparisons. I'm also giving you a few hints that if a name of a substance ends in ane, ene, or ine, it's a nonpolar organic substance, but if it ends in an -all, then it's going to have it's going to be an alcohol, and it has H bonding because this is going to have an O and an H on it, and the OH is connected to something. So you can see right here, this has an OH. So this one's going to have H bonding. However, this is just C's and H's, C's and H's, C's and H's, so we're all nonpolar. Remember, this ends in an ane, ane, ane. So this is all going to be London dispersion forces, London dispersion forces, London dispersion forces. So based on the notes you watched on the video, you want to now put these into an order of, it says decreasing intermolecular forces. So decreasing intermolecular forces. So what I would do if I were you is I would write that right here. So decreasing intermolecular forces means strong to weak. So strong forces to weak forces. That way you won't get mixed up. So out of all these, the strongest is H bond, so that's going to be the CH3OH. Now, the rest of them are London dispersion forces. So when you want to compare London with London with London, the bigger the cloud, the bigger the polarizability, which means the shifting. So therefore, the bigger the cloud, the stronger it is. So this one has the biggest cloud. So this one's going to be a C3H8, followed by C2H6, followed by CH4. This is all based on size. Remember, we looked at that graph for boiling points. The bigger the size, the stronger the London dispersion forces. So that's how you're going to do this whole worksheet on this page, which is intermolecular forces 1. Now we're on intermolecular forces 2. This is also designed to be just H bonding, just dipole-dipole, and just London dispersion forces. So again, if it's an ane, ene, or ine, it's going to be a nonpolar London dispersion force. If it has OL, it's an alcohol because it has H bonding. So if you look at HCl, you see that H is attached to Cl, but Cl is not part of FON. So this is just going to be a polar molecule, which is going to be dipole-dipole. You might have to draw this out yourself to figure it out. So if you drew it out right here, HCl, you would notice that this is going to be polar. So you know that's going to be dipole-dipole. So this is dipole-dipole. Now you really don't have to draw HBr because it's going to be the exact same drawing except a Br there. So you know that's going to be polar, that's going to be dipole-dipole. You really don't even have to draw Cl2 because you know it's a Cl with a Cl, so that's going to be nonpolar. So that's going to be London dispersion forces. And H2 is also going to be nonpolar because it's just an H with an H. So that's also London dispersion forces. So now we're going to go to the bottom of the paper and figure out what order we need to have. So this says increasing intermolecular force, increasing intermolecular force. That means you're going from the weakest intermolecular force to the strongest intermolecular force. So the weakest ones are London dispersions. So now we have to figure out which of these is the smaller. That's going to be the weaker one. It's definitely going to be H2. So that's an H2 followed by the Cl2 because that's a bigger size. But now we're in a new category when we go to dipole-dipole, but we still look for a bigger size. So this is a bigger size, so it's going to be stronger. So HCl is going to be a little weaker. So we're going to put the HCl here, and we're going to put the HBr right here. And this is how to do intermolecular forces 2. This is intermolecular forces 3, and this one again is just going to be H bonding, dipole-dipole, and London dispersion forces, so it's exactly the same as the previous worksheets. Now, intermolecular forces 4 worksheet actually has all of the possibilities, all 6 of them, in the worksheet. So let's look at number 1. You could see a metal and a non-metal with a plus and a minus, so that's going to be ionic. You could see NH3, which is molecular, but H is attached to Pon, so that's going to be an H bond. You see in the next one is just a plain old metal by itself, so this has to be metallic. And then this is a covalent compound which you have to draw, so you might have to double check, although you might remember this from all the ones we did. This is going to be CO2 is going to be big linear, and it's going to be nonpolar, so that's going to be LDFs. So now you're just going to go to the bottom, and you're going to compare all these together. This says decreasing boiling point. So decreasing boiling point means high boiling point to low boiling point. And remember, if you have a high boiling point, you have strong intermolecular forces, and this one has low intermolecular forces. So who's the strongest out of ionic and H bond and metallic and LDFs is going to be ionic based on the chart I gave you before. So this is going to be ionic. So it's going to be the LiCl. Next is going to be metallic, followed by Na. And then H bond is going to be stronger than LDF, so you're going to put this, you're going to put this. So you just basically have to figure out their categories, and once you have the categories, you're going to put them into the correct order that we learned before.